I'm Anil Kumar, and here is a solution for our test problem, which is an application question on sequences in series. The question is, thanks to improved vaccines and good public health policy, the number of reported cases of the gamma virus has been dropping by 70% a year since 2010, when there were 1 million reported cases of the virus. If the present rate continues, how many reported cases of the virus can be predicted by the year 2016? And part B is, how long will it take to eradicate the virus? Now, to answer this question, let us say that let n be the year after 2010. Okay, let n be the year after 2010. So normally when we say a geometric series, 2010 will be our first year, but 2011 will be the second year. But when we say n is a year after 2010, then the second year n value becomes 1. Remember that part, right? So we say let n be the year after 2010, right? So in that case, what happens to the number of virus as related with n? Now, n is not the number 1 and 2, but n is the number of years after 2010. Now, in this kind of an application question, this is a very critical way of defining, and it helps to understand and solve the problem in a better way, right? So in that case, the reported cases of virus predicted by the year 2016 should be how many? That is what we need to find. So in that case, for 2016, n is equals to what? In that case, n will be 2016 minus 2010. Is it okay? Which is going to be 6. So value for n will be 6 for us in our case. Now what we know here is that in 2010 there are 1 million cases. So the number of cases in general will be defined by 1 million cases, which is 1,000 times it has been dropping by 70%. That means 1 whole minus 70%, right? To the power of n. Now this can be simplified. We can say 1 million 100 minus 70 over 100 to the power of n, which is 1 million, 30%, right? So 0.30 to the power of n, correct? When you solve this, you get that. You could have written it directly also, but I went through all these steps for you to understand clearly why do we get 0.30 as the number of virus cases reported after every year. That is why 1 minus 70%. Okay, so that is the value. Now a for n equals to 6 is how much? That is what we need. So we say 1,000, which is 1 million, 0.30 to the power of 6, since n is 6 for 2016. So we can now use calculator, find our answer. So we have 1 million, 1,000, within brackets, 0.30 to the power of 6, and that gives us 729. So we get 729 as the reported cases. So that is the solution for part A, right? So for part A, it will be 729 cases. Now let's do part B. It says, how long will it take to eradicate the virus? Eradicate here means a virus cases less than 1, right? So let us assume it is 1, and then we'll see what number we get. So we get 1 equals to 1,000, 0.30 to the power of n, correct? We need to find the value of n. So we can divide 1 by 1 million. So we get 1 over 1 million equals to 0.30 to the power of n. Now to solve this equation, what can we do? We can actually take log both sides, right? So if I take log both sides, I get log of 1 over 10 to the power of 6, we can write, or let me write 10 to the power of 6, equals to n times log of 0.3, and solving for n we get n equals to log of 1 over 10 to the power of 6 divided by log of 0.3. So that is the value of n. So let's use calculator and calculate. So we have log within brackets 1 divided by 1000 equals to divided by log of 0.3 bracket close equals to 11.474. So we get 11.474, right? That is the value of n when the number of virus cases will be 1. Now we want less than 1, so it has to be more than 11, right? So the year should be, we can say it will be 12 years. So after 12 years, it will be totally eradicated. And which year will it be? That is the question. So our answer should be, this is n, and is number of years after 2010. So it should be 2010 plus 12, correct? So we get 2022. So in 2022, we expect if the same rate is maintained, then the number of cases will be almost zero, eradicated, correct? So that is what the solution is. I hope that helps. Thank you.